Deep in a climate-controlled laboratory, a team of geneticists recently held a small, weathered envelope containing a few strands of hair. They looked like ordinary relics of a bygone era. But these weren't just any fibers. They belonged to the man who once held the entire European continent in his iron grip, a man whose very name inspired both terror and adoration from Moscow to Madrid. Napoleon Bonaparte. For 2 centuries, the world thought it knew everything there was to know about the little corporal. We had his letters, his battle plans, and the memoirs of those who watched him draw his final breath on the lonely island of St. Helena. But history is written by people, and people lie. However, does not. When scientists finally cracked the genetic code hidden within those historic strands, the results didn't just clarify a few historical footnotes. They sent a shockwave through the hallowed halls of European academia, overturning centuries of assumptions about Napoleon's heritage, his health, and the mysterious circumstances of his passing. If you think you know the story of the emperor, prepare to have your perspective completely shifted, because the biological blueprint of Napoleon Bonaparte tells a story far more complex than any textbook ever dared to suggest. The journey to uncover Napoleon's genetic secrets began with a simple but profound question. Where exactly did he come from? We know he was born in Corsica, an island that had only recently become French when he arrived in 1769. His enemies often mocked him for his Italian roots, calling him a foreigner and an interloper. But the DNA analysis revealed a much deeper, more ancient story. By examining the Y chromosome of the Bonaparte line, researchers were able to trace Napoleon's paternal ancestry back thousands of years. The results were unexpected. Napoleon belonged to a specific genetic group known as haplogroup E1b1b1c1. This wasn't the typical genetic signature of a Western European aristocrat. Instead, this lineage has its deepest roots in the Near East and North Africa. It suggests that the Bonaparte ancestors likely migrated from the Levant to Italy or Greece during ancient times, perhaps during the expansion of the Phoenician or Greek maritime empires. Imagine the irony. The man who became the ultimate symbol of French national pride and European conquest actually carried the genetic markers of the very regions he sought to influence during his famous Egyptian campaign. This discovery immediately reframed Napoleon, not just as a Corsican or an Italian, but as a child of the Mediterranean in its broadest, most ancient sense. But the scientists weren't content with just mapping his ancient migrations. They wanted to tackle the most controversial mystery of all. A fierce debate has raged. The official autopsy performed by British doctors on St. Helena concluded he succumbed to stomach cancer. However, many of his supporters remained skeptical. They pointed to his symptoms, his sudden decline, and the suspicious behavior of his British captors. In the 1960s, a Swedish dentist and amateur historian used an early form of nuclear analysis to detect alarmingly high levels of arsenic in hair samples believed to be Napoleon's. For decades, this was seen as the smoking gun. The theory went that the British, or perhaps a traitor in his own inner circle, had been slowly dosing his wine or food with poison to ensure he would never return to Europe to cause another revolution. Modern genomic and chemical analysis, however, has added a fascinating twist to this tale. When researchers re-examined the hair using 21st century technology, they did find arsenic. In fact, they found a lot of it. But here is where the science gets truly mind-bending. The scientists didn't just test Napoleon's hair from the end of his life. They tested samples from his childhood, from his time as first consul, and from his glory days as emperor. What they discovered was that Napoleon had high levels of arsenic throughout his entire life. In fact, the levels were relatively consistent from his youth until his passing. This discovery suggests that the high arsenic wasn't the result of a deliberate assassination plot. Instead, it was a reflection of the toxic world of the early 19th century. Arsenic was everywhere back then. It was in the dyes of the wallpaper. It was used in hair tonics. It was in the glue of book bindings. And it was even used as a common preservative for food and wine. Napoleon wasn't being targeted by a secret assassin. He was living in a time before we understood the dangers of the chemicals we surrounded ourselves with. The DNA and chemical data strongly suggest that while arsenic was present, it wasn't the primary cause of his departure. The genetic analysis actually found markers that predisposed him to gastrointestinal issues, lending weight back to the original cancer theory, but with a modern understanding of how environmental factors might have accelerated the process. The investigation then moved into the realm of his physical traits. We've all seen the paintings. Napoleon is often depicted as short, though we now know that was largely a result of a confusion between French and British units of measurement. But what did his genes say about his appearance? Scientists found that he carried allele associated with a fair complexion and light-colored eyes, likely blue or gray, which matches many contemporary descriptions. They looked at his metabolic markers. Napoleon was famous for his incredible energy. He could work for 20 hours straight, dictate letters to multiple secretaries at once, and sleep for only 4 hours a night. Researchers found genetic variations related to his circadian rhythms and dopamine processing that might explain this legendary stamina. He was, quite literally, biologically wired for high-intensity leadership. This wasn't just a man with a strong will. This was a man whose biological machinery was optimized for the relentless pace of an empire builder. However, this high-energy blueprint came with a hidden cost. The same DNA that granted him his drive also revealed a vulnerability to certain autoimmune conditions. The researchers identified markers for something called familial Mediterranean fever. Throughout his life, Napoleon complained of mysterious, agonizing stomach pains and episodes of extreme shivering. During the Battle of Borodino, at the height of his Moscow campaign, witnesses noted that he seemed unusually lethargic and dazed, suffering from a sudden decline in health that may have influenced his decision-making on the field. The genetic discovery of this fever condition provides a clinical name for the Napoleon's malady that has puzzled historians for generations. It shows us an emperor who was constantly battling his own body while he was battling the armies of Europe. Another stunning revelation from the DNA study involved Napoleon's direct descendants. For years, several people around the world claimed to be the illegitimate offspring of the emperor. Napoleon was known to have many affairs, and the question of his biological legacy has always been a point of fascination. By establishing a clear genetic profile for the Bonaparte line, scientists were finally able to put these claims to the test. They invited individuals from the current Bonaparte family, including Prince Charles Napoleon, to provide samples for comparison. This allowed the team to verify the authenticity of various relics. They confirmed that a blood-stained handkerchief from the battlefield and several tufts of hair held in private collections were indeed a match. But more importantly, it helped settle long-standing disputes about certain noble families in Europe who claimed a secret imperial connection. In some cases, the DNA confirmed the legends, proving that the emperor's biological footprint is still walking the earth today in ways we never fully realized. The scientific analysis also shed light on the mental state of the emperor. While we can't sequence a personality, we can look at markers related to stress response and emotional regulation. The results suggested a high level of resilience, but also a tendency towards extreme neurobiological reactions under intense pressure. This aligns with his historical behavior, a man who could be incredibly cold and calculated one moment and then prone to fits of intense emotion the next. It's a fascinating look at the neurological foundation of a man who changed the laws of France, the borders of Europe, and the way we think about modern warfare. His brain was as much a product of his unique genetic combination as it was the product of the Enlightenment era he grew up in. One of the most heartwarming, or perhaps tragic aspects of the study involved the comparison between Napoleon and his son, the King of Rome, also known as Napoleon II. The young boy was taken to Vienna after his father's fall and lived his short life under the watchful eye of the Austrian court. He passed away at only 21 from tuberculosis. Scientists were able to examine samples from the son as well. The DNA confirmed the heartbreaking parallel between father and son. Both possessed a genetic predisposition for weakened pulmonary systems. It creates a sense of genetic tragedy. A father and son separated by oceans and politics, yet bound by the same invisible vulnerabilities that would ultimately limit their time on this earth. The impact of these findings has completely transformed the way museums and curators handle Napoleonic history. For centuries, museums have bought and sold items based on provenance, or the paper trail of who owned what. But paper can be forged. DNA cannot. Since the publication of these genetic results, a massive effort has been undertaken to biologically authenticate Napoleonic collections across the globe. This has led to some embarrassing moments for certain institutions who realized their prized locks of hair were actually from 19th-century horses or unrelated servants. But for the lucky few, the DNA has confirmed that they are holding the actual remains of the man himself. It has turned history into a hard science, where a pipette and a sequencer are now just as important as a dusty archive. But let's go back to that mystery of his final days on St. Helena. The DNA research has allowed scientists to reconstruct his diet and environment in far greater detail than ever before. By analyzing trace elements in his hair and the genetic markers of the microbes found in his remains, researchers have started to piece together a new theory of his decline. It wasn't just the cancer and it wasn't just the arsenic. It was a perfect storm of environmental factors. Moldy environment. The emperor, used to the grand palaces of Europe, was confined to Longwood House, a building that was notorious for its poor air quality and dampness. Scientists found evidence that he may have been suffering from chronic liver issues, possibly exacerbated by the local water and the lack of exercise. The DNA shows a man whose system was already under stress from a lifelong autoimmune condition, being placed in a high-stress, toxic environment. It wasn't an assassination in the traditional sense, but rather a slow biological erosion caused by the conditions of his exile. This brings us to a larger conversation about the ethics of analyzing the DNA of historical figures. Some argue that an individual, even an emperor, should have a right to genetic privacy, even long after they are gone. Others argue that Napoleon belongs to history, and that understanding his biology helps us understand the decisions that shape the world we live in today. For the scientists involved, the goal wasn't to gossip or to sensationalize. It was to use the tools of the future to solve the mysteries of the past. They see it as a way of humanizing a man who has become more of a myth than a human being. When you see his DNA sequence, he stops being a figure on a white horse or a marble statue in the Invalides. He becomes a person with allergies, with predispositions, with a family history. He becomes one of us. The shock that this study caused in Europe cannot be understated. In France, the Bonaparte name still carries immense weight. The discovery of his Levantine origins was particularly impactful, challenging traditional notions of French identity. It reminded everyone that the greatest Frenchman was actually a product of the vast, interconnected migrations of the Mediterranean world. It celebrated the idea that genius and leadership can emerge from a blend of cultures and ancestries. It made Napoleon a more global figure, a bridge between East and West. As we look at the results of this genetic investigation, we also have to consider what it says about our own understanding of science. We often think of history as something static, something that happened and is now over. But science shows us that history is alive. It's written in our cells and passed down through generations. These scientific techniques are now being applied to other figures. We are looking at the DNA of Egyptian pharaohs, of medieval kings, and even of the victims of ancient natural disasters. Each time we sequence an ancient genome, we find things that the contemporary chroniclers missed or didn't have the words to describe. We are entering an era of deep history, where the biological record is just as important as the written one. The stunner for Europe wasn't just the specific facts discovered, like the haplogroup or the autoimmune condition. It was the sheer power of the technology. The idea that we could reach back through 200 years of decay and find the blueprint of a man's mind and body was a wake-up call for many. It proved that the mysteries we think are buried forever might just be waiting for a more powerful microscope. It has sparked a renewed interest in Napoleon, not just as a conqueror, but as a biological specimen. Biographies are being updated, documentaries are being filmed, and a new generation of students is looking at the Napoleonic Wars through the lens of medicine and genetics. Another fascinating ripple effect of this research has been in the field of modern medicine. By studying the genetic profile of a man who lived a high-stress, high-performance life and understanding his specific physiological failures, doctors are gaining insights into how similar profiles react in our modern world. Napoleon's life was an extreme case study in the interaction between genetics and environment. He pushed the human body to its absolute limit while living in a world full of unseen toxins. By deconstructing his biological end, we are learning more about how to protect people today who face similar pressures, though hopefully without the part where they try to conquer Russia in the winter. The DNA results also provide a unique window into the sheer luck of history. When we look at Napoleon's genetic markers for health, it's clear that he was a survivor. He survived countless battles where men were falling all around him, and he did so while frequently being ill with his recurrent fevers. There is a sense that his biology held on just long enough for him to complete his historical mission. If his genetic predispositions had caught up with him 10 years earlier, At the height of his power, the entire map of the world would look different today. There might have been no Napoleonic Code, no unification of the German states, and no Louisiana Purchase. Our entire modern legal and political framework was resting on the biological resilience of this one man. What the scientists did was bridge the gap between myth and reality. For a long time, we viewed Napoleon's decline on St. Helena as a poetic tragedy, the broken eagle of France sighing his soul away into the Atlantic mists. The DNA has replaced this poetry with a more grounded, perhaps more profound, reality. He was a man who was hurting. He was a man whose body was finally giving up after decades of being pushed beyond the breaking point. It reminds us that behind every great historical event, there is a human being who feels pain, who gets tired, and who is subject to the same laws of nature as everyone else. The legacy of this study will likely last for decades. As DNA sequencing becomes even more advanced and even cheaper, we may be able to find even more subtle clues. Perhaps we can find out exactly what he ate during his final days, or what the specific strain of tuberculosis was that affected his son. The envelope of hair, once just a curious relic, has become a library of information that we are only just beginning to read. The results have indeed stunned Europe, not by creating a new legend, but by refining the one we already have. They've given us a version of Napoleon that is more complex, more vulnerable and more fascinating than any version we've seen before. In the end, the genetic analysis of Napoleon Bonaparte is a testament to human curiosity. We have an insatiable desire to know the truth, to peek behind the curtain of time and see things as they really were. By looking into the DNA of the man who once dominated the world, we are really looking into ourselves. We are looking at the fragility of life and the endurance of legacy. We are seeing how a single life can be shaped by ancient migrations, by invisible chemicals, and by the hidden codes of our own biology. Napoleon may have passed away 200 years ago, but thanks to these scientists, his story is far from over. It is being rewritten, letter by genetic letter, providing a new map for understanding one of the most remarkable lives ever lived. The next time you see a portrait of Napoleon, with his hand tucked into his waistcoat, remember that he wasn't just posing for a painter. He might have been pressing against a real, physical pain that was coded into his very origins. He wasn't just a man of his time, he was a man of his biology. And while his empire has long since vanished, the molecules that made him who he was are still telling his story to anyone with the technology to listen. The biological reality of the emperor has finally caught up with the legend, and in that intersection, we find a truth that is far more stunning than anything we could have imagined. History has many voices, but the voice of the genome is perhaps the most honest of them all. It reminds us that while we cannot change our past, we can always find new ways to understand it. Not in the form of a ghost, but in the form of information, waiting to reveal the next secret of the man who once shook the world. As researchers continue to explore this biological data, they are also finding links between Napoleon's line and the broader history of European nobility. It turns out that the genetic map of the continent is much more entwined than the political borders would suggest. The Bonaparte legacy is a tapestry of Mediterranean history, interwoven with the ancient threads of the Levant and the modern threads of the French Republic. This scientific breakthrough has forced Europe to look in the mirror and see a history that is not characterized by purity or isolation, but by a beautiful, chaotic, and powerful mix of influences. Napoleon was the ultimate product of that mix, a man whose genes were as revolutionary as his ideas. Through his DNA, we see the true face of the man beneath the bicorn hat, a man of flesh and bone, of code and history, who continues to stun the world long after his final campaign ended on the shores of St. Helena.